Student, we have to continue the topic heat transfer, and in that we have to just recap thermal expansion. Thermal means heat, and expansion means something which expands. So it can be solid, it can be liquid, or it can be gases. Students have already sent you some videos related to it, and I hope all of you have gone through that and understood the topic properly. Okay. It has been experimentally observed that when a substance, that is solid, liquid, or gas, it is heated, it expands, and when it is cooled, it is contract. It is contracted. So when something is cooled, it will contract, and if it is heated, it will expand. Now there are some exceptions which you have to learn by heart, and it is water, silver, iodide, silica, which contract on heating and expand on cooling. So this is opposite. Water expands from 0 to 4 degrees Celsius, and silica, the temperature is 80 degree to 141 degrees Celsius, and silver iodide, it is 80 degree to 141 degrees Celsius. Silica is 80 degrees Celsius. And next one is thermal expansion in solids. Now, thermal expansion in solid is explained by this activity in which the ring passes in winter, but ring do not pass in summers. So when this ball is heated, when this solid ball is heated, it expands and it is not able to pass from this ring. But in winter, it has been seen it easily passes through the ring, because in winter it is in contracted form, and in summers it is in expanded form. So the next experiment is the bar and the gauge setup as shown in figure 6.4a. It consists of a metallic bar and metal gauge attached with a handle. The bar just fits into the gauge when both are at room temperature. It just sticks in this gauge, but in summer it has been observed that it do not stick in this gauge because of expansion. Now in expansion, it has been seen there are some expansions, that is linear expansion and superficial expansion or aerial expansion, and the next one is cubical expansions. Now linear expansion is lengthwise expansion, that is when a solid in form of rod or wire is heated, only linear expansion, that is increase in the length, is effective. So what factors we see? Original length of the rod, increase in temperature, and material of the rod. What kind of material is being used? Is the rod made up of iron or rod made up of copper or whatever? So dependence on original length of the rod means if we heat two rod of the same metal, one short and other long, to the same temperature, we will find that long rod expands more than the short rod. And the next one is dependence on increase in the temperature. If we heat two identical rod, means similar rod, at higher temperature than the other, we find that the rod heated to higher temperature expands more. It's very simple. If we give more temperature, it will expand more, and if we give less temperature, it will expand less. Dependence on the material of the rod. If we heat two rod of the same length, but one of copper and the other of iron, so you will see that copper will expand more than the iron, because absorption of heat capacity of copper is more than the heat capacity of the iron. So dependence of the material, it also depends upon what kind of material you have taken. Next is the some terms given related to this. It is L0 is the length of the rod at 0 degrees Celsius, and its length at 10 degrees Celsius is LT. So increase will be taken as LT, that is final minus initial. So LT minus L0, which will be equal to constant value, that is alpha is called the coefficient of linear expansion which expands on the material of rod. That is alpha is different for different substance. Its unit is per degree Celsius. So that is it will be in final minus initial, which will be equal to L0 alpha T. It is written like this. Now there are some activity which you have to go by yourself. Activity 2 and 3 is given, in which it is explaining about the linear expansions. Next one is superficial, that is aerial expansion. And in aerial expansion we are having initial area of the plate and increase in temperature and material of the plate. Again, as we have seen in linear expansion, it is if A0 is the area of the plate at 0 degree Celsius and AT is the area of the plate at T degree Celsius, the increase in area will be final minus initial, that is AT minus A0, which will be written as A0 beta T. This is called beta, where beta is the coefficient of superficial expansion, which is different for different solids or materials. So area wise superficial expansion means area wise expansion, when some solid expands area wise. And the next part is the cubical expansion. Cubical expansion is initial volume of solid, increase in temperature and material of the solid. Again we have volume wise, that is for volume we will take V. So Vt minus, that is final minus initial, will be equal to V0 gamma T, and gamma is called the coefficient of cubical expansion of solid. It is different for different material. What is the relationship between alpha, beta and gamma? It is written as alpha beta gamma, which is beta is 2 times alpha and gamma is 3 times of alpha. So in ratio, if you have to write in ratio, it is alpha is to beta is to gamma will be equal to 1 is to 2 is to 3. Now some applications of thermal expansion of solid in daily life. This first one is the construction of the bridge, and in construction of bridge we have steel girders. I have already sent the video related to this. Steel girders are used at one end A of the girder is fixed is in concrete, but the other end B is not fixed into concrete or pillar. It is supported on the roller as shown in figure 6.7, so that if there is any rise or fall in temperature during summer or winter, the grider may expand. So this is the reason they are doing like this. The next is the railway track. You must have gone through the previous video which you have seen very properly, in that railway tracks, whenever railway track is given, some railway track is being laid, you see some gaps are always given between two railway tracks because of the expansion in summer. The next is riveting. Riveting is for joining two steel plates. They are placed one above the other, and holes are drilled through them. The rivets, that is small steel rods. Rivets are small steel rods, are heated red hot, and then they are inserted into the holes for the plates. On heating, the rivets become soft, so their ends are easily hammered as heads. Now the rivets are allowed to cool. On cooling, they get fitted into one another very properly. So this is what being explained in this. On contraction, but they cannot regain their original size as they have been hammered. So they bring the plates closer and firmly gripped them together, making the joints waterproof Such riveting is used in joining steel girders, boiler plates, etc. The next one is the electric cable and telephone wires. Now, if you see the two cables joined with the wires, in summer it is bent and in winters it is stretched. This is also because of the application of expansion and contraction. The next is fitting of the steel ring into the horse cart, glassware. These are the application which we see in our daily life. Glassware used in kitchen. Pendulum of the clock is made of invar. Invar is a type of material. Loosening a glass stopper or a metal screw cap and cracking of thick tumbler. The next topic is thermal expansion in liquids, and this also we have done. This activity you have already gone through. That when this type of experiment is done and the bottle is taken filled with water, and when you heat and put a capillary over here, you will see rise in water. But when you heat this, you will see more rise of water because of expansion of water. So this experiment is already being sent to you. The next one is the thermal expansion of liquid by molecular motion, and is a recap of previous things which we have done already. Factors affecting the cubical expansion of liquid is original volume of liquid, rise in temperature, and nature of liquid. What kind of liquid is taken, whether it is water, alcohol, or oil or other. It depends upon that also. The next activity is different type of material is taken and rise is observed. You can see the benzene. In benzene the rise is maximum because the heating capacity is different. All the heating capacity of different materials are different. It has been shown in this experiment. Next is thermal expansion in gases. Now with activity they have shown that two bottles are taken and it is fitted with balloon at their mouth. Now before heating, this is the time when the bottle is not heated, so you will see the balloon is deflated. But when you will heat the bottle or put the bottle in heating bottle means you have to put bottle in hot water, and after that you will see a boiling water, you can say, you will see that the balloon is inflated because of the temperature which has been, that is the vapors, and that is why gases also expanded. On heating. So with this experiment it is proved that gases also expand on heating. Next part, I'll give you the assignments and the question answers of the chapter related to this.